Alright everybody, I'm going to show you how I do my skew test. There's other models out there like the cauliflower, there's the YACS test on Thingiverse. They're all good tests, but I feel like the cauliflower test is just too much material and too much time to check skew. So what I do is I print these little squares, and it's a square, and then there is a defined edge over here on the side where I can measure my diagonal. And this is a really quick test that I use. I can get this done. It usually takes me about 4 or 5 of these to print to get it just right. But I'm going to show you what I do to check it. And so recently I just did my rail tramming, and I like to check it afterwards to see, how it came out. It is off a little bit. It's not much. I'm going to go ahead and correct it in software, and you can do the same with your printer. If you have Marlin or Clipper, they have skew correction in there. In Marlin you have to enable it, and also in Clipper you have to enable it. So I also want to kind of show off my new tool head here. So I've changed this again. My tool board in the back here was mounted higher, and this piece was attached to this lower plate on the back side, and it was vibrating. And so I started playing around with some tests, and sure enough the acceleration picked up by me moving this around, or actually I had taken a tie wrap and pulled it over here to the extruder, and the numbers changed. So this was affecting my results. So I just went ahead and made a whole nother extruder mount, and I've lowered this even more. This heatsink now is only 9.5 millimeters tall, and the motor is sitting on the lower plate, and it's shifted over a little more. So the center of gravity is a little bit better this way. This picked up about 4,000 acceleration by moving this over and down. I couldn't believe it. It's pretty rigid. It's now attached to the motor with standoffs, and it seems like it's going to work. So let me go ahead and start this print and just show you how fast, how quickly you can get this done and get your skew corrected. I'll take a minute here to start this. I'm now using a purge blob in the corner because it just seems to work so much better than a purge line. That blob comes right off. It doesn't go up underneath your fingernail and cause you have to put a band-aid on there, and you can just pull it right off. So depending on the caliper size you have, you may need to make it smaller. This is 130 millimeters on the square. In diagonal it's around 183 millimeters. I use 999 walls. I don't bother with any infill. Make sure your seam is not going to be on that diagonal edge of those squares. You could print it slower, it doesn't matter. I like to do the calibration at the speed I print at, so I just got it set kind of, I don't know, 15,000 acceleration, maybe at 300 millimeters a second. And I think I have this maybe 5 millimeters tall. It really doesn't even have to be that tall. But you have to be able to lay your caliper on the side in order to hit that diagonal edge. So you can do this, whatever speed you print at would probably be ideal. Who knows, you might get some different results going slower, or maybe some different results even going faster. But I expect the machine to work accurately at the speed that I print at. If it doesn't work accurately at that speed, then I need to slow it down. Now, if you don't have a removable, a magnetic sheet, you're going to have to get in there with the calipers on your machine and fit it in there somehow and make these measurements. For me, I just have to remove the sheet. I set it on a table. I put a piece of glass in the center to hold it down so it doesn't warp up, and then once it cools, it'll stay flat. And then I take my measurements. Okay, so at this point I would take this off and I would set it on a table, and it wants to warp up in the center pretty easily. And I also have some glue stick down to make sure these guys don't pop off when it cools down. They won't pop off with glue on there. Just some Elmer's purple, Elmer's white, this fly doing in here, will work just fine. So now keep in mind, this is ABS and there's some shrinkage, and if you try to measure this when it's hot, as it cools your numbers are going to change right before your eyes, so you need to wait a little bit of time anyway to get your measurements. Now the way this works is, this is A, B, C, and D, and this is AC, and this is BD. So what I do is I measure on this flat on this side over to this flat on this side, and I get my Y dimension. And it should be the same across these two, and it should also be the same going across B to C and A to D. They should all four be the same. So this is a chance right here for you to measure your X and Y to make sure the dimensions are where they're supposed to be. Now it's not important so much, like this is 130 millimeters across, this is 130 millimeters square. You got some shrinkage, so you need to kind of know what your shrinkage is. You can start by printing with no horizontal expansion in your slicer and see what you get, and then change your horizontal expansion so that you get your 130 millimeters. Now for some reason, if you get 130 millimeters on X and you get 130.1 on Y, you may need to change your rotation distance, you know, or your steps, so that you get the same on X and Y. It's pretty important. You could have some wear in your pulley, you could have a little smaller diameter somewhere, something. Even though your mechanical ratio says you should be at 40, well, maybe you need to change that. You're not going to be able to change your XY compensation differently for each direction. So that'd be a time to change your rotation so that you get your X and your Y the same. That's how I do it. Some of you may cringe at that and say, man, my mechanical is 40. I don't want 39.9. I don't want 40.2. That's up to you. This is how I do it. I will change my rotation distance so that they match. In my case, one of my axes is off slightly. It could be a worn pulley. I don't know. I don't care really. As long as it prints the way it's supposed to, the dimensions are right, I don't care. So like I say, you will measure, and I can't do it. I can do it this direction. You'll measure across here. Okay. Make sure they're the same. Change your rotation, whatever you got to do. Change your, as long as they're the same, you have to change your rotation. The numbers don't matter if they're exactly 130. It doesn't really matter. It just matters that they're the same. So when you do the math for the skew correction, you get it right. So once I get that right, I'm going to measure diagonal, and hopefully they come out the same. If they don't come out the same, then I'm going to have an Excel spreadsheet where I put in the values that I get for X, Y, and then my A to C and my B to D. And then it's going to give a recommended amount to change it, and then I'll change it based on that. Now Marlin and Clipper allow you to put in the dimensions that you get, and then it will do the calculation for you. I just prefer to use an Excel sheet because I can look at those numbers and I can tell which direction I need to move it. Because even though you measure this and you put the numbers in, you can go back and test it again and it can still be wrong. I don't know why, but that's how it works for me. It never comes out right. I always have to move a little bit more, a little bit more, a little bit more, and sometimes, oh, I went too far. And the numbers will shift. You know, instead of this direction being longer than this direction, it'll switch. And this will be shorter and this will be longer. So you may have to print a few times in order to get that right. But it's pretty important. I make templates for hole patterns, and if when I center punch it, it's not right, then it's not going to come out right. So I have to make sure that the machine is printing the way it's supposed to. So these are, like I say, these are really small squares. It doesn't take long at all to print that. They come out super clean. I mean, super clean. Really easy to do, and your machine is going to print square. So you print those 20 millimeter cubes and you measure, you know, the width of them, but I don't see often people measure them diagonally. So it's important that your cube is dimensionally accurate diagonally both ways. That makes sure that your cube is an actual cube, a square, and it's not doesn't have the skew off. So I think I may have these on Thingiverse already. I'm not sure if I do or not, but I'm going to go ahead and post these on there, and if you want to try this, you can. You know, try it out and see how you like it, and if it's, you know, it doesn't take long. You can get this done in a pretty quick amount of time. You know, there's the cauliflower does test for other things. Inside dimension, I'm not sure if it does holes or not. I think they're mostly squares, but it's just another thing to try that's quick, so you don't have to sit around too much and print and wait and waste your filament and all that. This goes by, you know, really quick. So anyway, adjust your skew.